So after that, we are going to process the data. Okay, so process the data with MapReduce, or you can say the yarn. So you have the two things are available. So the MapReduce, that's a before Hadoop 2.0, we can use this one, or we can use yarn, the newest version of the Hadoop. We are having the yarn. So store the data and after process the data, right? So in the previous session, we have seen that, so we are getting the bulk amount of data, like the data which is in terabytes of data or petabytes of data or exabytes of data. And the data can be any type of the data, like it can be a structured, or it can be unstructured, or it can be a loosely structured. Or in the sense, in a simple terminology, we have a CSV files are there, TSV files, XSV files, Parquet files, RCF files, XML files, JSON data, and the files generated by the user, the data generated by the users, the data generated by the applications. In the sense, we are all having the mobiles, correct? So iPhone 6 we are having. So how many users around the world using this iPhone 6? So now whenever you work with an application, right, your mobile get crashed, some issue arises. So now your device is going to be restored back, right? So it's restarted something. Now otherwise you're working with the Windows, your system got crashed, then you'll get a message, you want to send error report to the manufacturer, right? Now what we'll do, now we all press yes, right? In my mobile, I send this feedback to the manufacturer. Now, so what Apple has to do, now Apple has to collect all these kinds of errors from the mobiles, means here the data generated by the machines. Now you need some mechanism, you need you need to apply some analytics on the data generated by the machines, correct? And how much data you are going to get, right? So there are many users are there around the world who is using this particular mobile. And whenever you're coming with the next update, right, when you're coming with a new release, so in that case you should able to identify the issues in the existing version. You need to bug fix the version issues. After that you need to able to resolve the issues into the next update, right? So here what you have to do, so get the data which are generated by the machines, and we are going to process the data which is generated by the machine. So the data can be generated by the users as well as the data which is generated by the machines. So we are going to process the data, right? So now uh, when we are trying to write the data into Hadoop cluster, why? uh, the thing, I'll give you one example. The Hadoop starts 1 terabyte of data. Hadoop starts 1 terabyte of data in a less than 3.5 minutes. See now how much faster we are running the jobs, right? The sorting 1 TB can be done in less than 3.5 minutes in a Hadoop, right? So this is the advantage when you work with the big data in a Hadoop environment. So when we are trying to write the data, Hadoop supports master and slave kind of architecture. Okay.
It's like an name node and data node,
Yes.
master and slave.
Yes, Hadoop supports master and slave kind of architecture. So what we have, okay. So first we'll see what are the masters nodes and what are the slave nodes. Okay. So before that we have a bunch of disks are there which we are going to write the data into the bunch of disks. See here, suppose I have a file, prad underscore info.txt is my input file. Okay, now I want to write this file into a directory in SDFS. Right, what is a directory in SDFS? This is we discussed, right? So what I did, I have took one disk. Okay, so in this disk I have configured the operating system, right? So that is, now this disk is having Windows or the Linux file system, correct? So that is, first get the disk or get the computer, and start working this device. That means I have to install OS. Either you can install Windows or you can install Linux. So here we are taking the Linux. So when I install the Linux, we'll get the Linux file system, right? Now in top of the Linux, what I did, I have configured the Hadoop. So when you configure the Hadoop, right, Hadoop will give you its own file system. So Hadoop uses SDFS file system. So the files which we are going to write into the Hadoop cluster, which we are going to process with the MapReduce, are the data which we are going to process with YARN. We should make the data available in SDFS. So this is a one disk. So when you install the operating system, we'll get a Linux file system. On top of this Linux file system, I have installed Hadoop. So when I install the Hadoop, so I'll get the SDFS file system, right? So like this, we have created a bunch of disks, right? So what we call now, so this is one disk. So like this, we can create multiple disks like this. So in each disk we have the local file system as well as,
The multiples like disk, like it's a multiple kind of clusters.
no, yeah, that's I'm going to teach you. Okay,
Oh,
this again,
okay.
right? So we'll have some like this, we are having the disks are there now. So right, how many disks we are having? Three disks. Now we are configuring each disk as a one node. So this is node 1, this is node 2, this is node 3. Okay, so in each node what we have a Linux file system is available, as well as SDFS file system is available. So now we call these nodes as the data nodes, right? Because the data which we are going to process, so you want to apply some analytics on the data, or you want to process the input data. So what you have to do, you should make the data available in the data nodes, right? The first thing,
Data node is like HDFS or Linux.
didn't get
In
you.
this, in this box, what is the data node?
Yeah, fine. I'll
HDFS or Linux?
right. So this each one is a, it's one disk, it's a one node, or it's a one disk. We have the Linux is available, as well as a Hadoop file system. Both are available. Okay, I'm going to show you that, Naveen. Just give me some time. Okay. So
Okay.
right, so now what we did, as per the definition, we have created a bunch of disks are there. So we have the three disks. We have configured each disk as a one node. So this is node 1, and this is node 2, this is node 3. And what is the definition? It's a distributed data processing system. So the data which we are going to write is going to be distributed to all these three nodes. So we have the data is available in a file prod underscore info, right? It's a text file. So this is the data is, right, where my input data is available now. So we are going to write the data into this bunch of disks. So the actual content of the data, right? So consider this file is having 1 GB file it is. Okay, so this 1 GB file, this product underscore info dot txt, equally distributed into all these three nodes. So these are the three data nodes. These are three nodes where we are going to write the data, so that we are calling these are the data nodes, right? we are calling as data nodes. So what is a data node? Actual data written to data nodes. So what is actual data? Now I have file is there prod underscore info dot txt. Now I want to write this file into the directory. So in a Hadoop file system, I have created directory Naveen. In this directory Naveen, I'm going to write a file prod underscore info dot txt, right? So we have a copy command is there. So I'm using copy from local some command, okay, to copy a file from the local file system Linux file system to the Hadoop file system. Why we have to copy this file into the Hadoop file system? Because to work with the Hadoop, to process the data with the Hadoop, to process the data with a MapReduce, to process the data with a yarn, we should make the data available in SDFS. Suppose you want to play a song in your system, what you have to do? Right, you have to make the song available in C drive, D drive, or somewhere into the system. After that, you have to double click it. Then you must have a player to play the song. Means to play the song, the first thing is you need to make the song available into the system. The same thing now, to process the data using Hadoop, you should make the data available in SDFS. So always we have to write our input data into the SDFS file system. How you get SDFS? When you install Hadoop into the disk, you'll get the SDFS. So now once we get the SDFS, we can able to copy a file from the local file system, from the Linux file system to the Hadoop cluster. So what I'm doing now, I'm copying this file with a copy from local to the directory Naveen. So what is the file name? Prod underscore info dot txt. So now this file is copied to the data nodes, right? So actual data, that is the content of the data which you are going to write, is distributed. After that, this distributed data is written into all available data nodes. Now we'll have a node which we call it as a master node. Now so we are going to write the files onto the disk. Suppose Naveen, you have given a textbook of 1 lakh pages, okay, and there is no index is available. I told you to find one paragraph. Is it possible?
No, it takes long time
It's
to
first,
search that one.
yeah. First thing is it is possible. We can able to pick the data from
No,
that. Possible, right? It takes a lot of time. You have to spend much time by searching, right? So you need to have multiple users. You have to work on that, right? We can able to find one particular paragraph from a big book, even though you don't have the index, but it takes a lot of time. You have to spend too much time on that. So what we have, if we have an index is available, then simply we'll go to the index. In the index we'll find in which page we have that particular chapter is available, then we are going to pick that one. The same thing now, we are going to write the data into the data nodes, right? In each data node we are going to create some directories and we are writing the files onto the directory. Now so in which directory which files are available, we have to make available somewhere. So for that we are using a node called master node, right? What we call it as a, we call it as a master nodes, or so, right, we call it as a masters. So all the slaves are connected to the masters, right? So now all these data nodes are connected to the master, that is name node. We call this as a name node. So what name node contains? Name node contains index of the data in data nodes, or name node contains metadata,
metadata.
or you can say the name node contains reference of the data, right? So these are written into the name. That is, now what we are going to write, we are going to write the file prod underscore info dot txt. Where I'm going to write, I'm going to write this into the directory Naveen, right? The same information in the name node, this will be written, right, in a directory Naveen. So there is a file is available with the name prod underscore info.txt. And what is the size of the file, and the user of the file, and the group of the file, right? So this information is written into the name node. Okay, so name node contains only the which data available in the data nodes are written into the name node. You can say index of the data or metadata or reference of the data is available into the name node, right? All the data nodes are connected to the name node, so we call name node is a master and the data nodes are the slaves. Clear? Now how we are going to store the data into the Hadoop cluster? So when you are going to write this file, so this file is distributed. I'll show you how the blocks are going to be created. Okay, now so what,
Yeah.
from a client, a user, right? That is from the user, he's trying to run a job. He want to count the total number of rows or users in, or the number of products in a file prod.info.txt. So he wrote a program. So what it is, some the client, so he wrote select star, or you can say count of star, some program, right, from prod underscore info. He want to know that. So when a user enters a query, when a user enters a job, now, so where this prod underscore info.txt is available in the job tracker, where prod info is available is written into the name node, right? In a Hadoop, we have a job tracker and task trackers are available, right? So the job tracker is a available in a as part of the name node. In every data node we are having the one task tracker, right? So if we are having the three data nodes, in each data node we'll have a task tracker. Okay, so see why Hadoop jobs are faster, because we are working on the place where the data is available. So here the data is available in this disk and we are executing the job in the same place. We are not getting the data somewhere and we are passing. Hadoop jobs are executed in a place where the data is available. I'm going to the place where the data is available and there I'm running the jobs. So this is the reason Hadoop jobs are faster, right? Now in a name node, we'll have a separate process is available. So that process we call it as a job tracker. Okay, so what this job tracker do? Right. Okay, so we have in a name node job tracker is available. So first what this job tracker will do, whenever a client submits a job, whenever a client submits a program, then this job tracker will take the request from the client, right? What is the request? To count the number of products in this one. So this job taken by the client, the client job is taken by the job tracker, and then job tracker goes to the name node. In the name node it will identify in which the data node the data is available, right? After that job tracker assign the job to the task tracker. Job tracker assign that job to the task tracker. Then task tracker will execute the job. Once the job is completed successfully, then the task tracker will give the output to the job tracker and the job tracker will send the output back to the client, right? So I'll repeat. We have the name node is available where which contains index of the data or metadata or reference of the data. So which data is available in which data node, where the data is available, that is written into the name node, and actual data is available into the data nodes, right? So
Right.
generally we have the job tracker is available in a machine where name node is available. Okay, so here the name node is available, so I have configured the job tracker in the machine in a node where the name node is available. That means job tracker and name node resides in a same machine. So whenever a client requested a job, or when a client submitted a job, the job tracker will take the job. Okay, and in the name node it will find the reference where it can find these blocks related to prod.info.txt, right? That will be written into the name node. So job tracker gets the information about this file and where these five blocks are available. Then job tracker goes to that particular data node, and this job is assigned to the task tracker and that data node. Then the task tracker will execute the job. Once the job is completed successfully, job execution is completed successfully, then the task tracker will give the output back to the job tracker, and
Job track.
job tracker will give the it back to the client.
Yeah,
Okay,
it's very good. It's very clear to me.
yeah, right. Now this is a basic thing. Now just a second.
Yeah, okay.
Naveen.
Yeah, yeah. I'm there.
Okay, right. So now this is a cluster. Actually, this cluster is a logical thing, right? So physically, it's not possible. A cluster is a collection of nodes. So where one node I'm configuring as a name node, and the remaining nodes I'm configuring as a data nodes. When you install the Hadoop, by default, we'll get this SDFS and we'll get the name node, right? That's we'll see the latter about how to start and everything. Suppose generally job tracker resides in the machine where name node is available. Okay, but there are the times when we are having multiple requests from the client. There are many requests are there from the client, and I cannot able to accommodate all those things one job tracker in this node, right? In that case, we can able to configure job tracker as a separate node. Okay, so most of the times job tracker resides in a machine where name node is running. Okay, suppose if you're having the many requests are coming from the client and you cannot able to accommodate that many number of resources in this node, then we can able to configure job tracker as a separate node. Okay, and second
Yeah,
thing
okay.
what you have to remember, in every data node we'll have the task tracker, right? If your cluster is having 10 data nodes, then each data node will having the one task tracker. Okay, so actually
Yeah.
the job is executed by the task tracker and job is assigned by the job tracker. So always the data storage where we are going to store the data can be taken care by the name node and the data nodes, and the job of processing is done by the job tracker and task tracker. Okay, so now coming to the master nodes, what are the master nodes? So we know that name node is a master node. Okay, so, and what is the next one? Job tracker is a master node, right? So this is, after that we have secondary name node is available. Okay, so don't think that secondary name node is a backup node. This is one extra node, right? So we'll see.
I think it's a backup
No, no,
name
it's
node.
no, it's not a backup node. Okay, so generally everybody will get confused that secondary name node is a backup node, but it's not a backup node. As of now,
Oh, if it is fails name node, it will takes the secondary node.
no, no,
Okay.
that's what it's not a backup node, right? So it's a secondary name node. As of now, just remember, a secondary name node is a snapshot of the primary name node. Okay. uh, the,
Yeah.
s- the snapshot. So whatever you are writing into the primary name node will be written to the secondary name node. Okay. As of now, remember this definition. The snapshot, right? Whenever the checkpoint occurs. So checkpoint occurs means you're going to save this metadata. That saved metadata for this particular point of time is written into the secondary name node. Okay. Right, so just remember
Yeah.
this, right? I'll will dig deep into this, what is secondary name node, how it works, right? So this is a secondary name node, is also known as a master node, right? So what you have to remember, we know the definition of the name node. Secondary name node, the snapshot of primary name node is written to secondary name node. Okay, so now we have a name node, job tracker, secondary name node, and we are working with HBase. Then HBase master is also the master node. And if you configure the Hive, then Hive server also we can configure as a master nodes, right? In a cluster, so these are all the master nodes. Then what are the slaves? Slave nodes are, what are the slaves now? Naveen? Data nodes are the
Then
slaves, and
task track,
data
task
nodes,
tracker.
right? Data nodes and the task trackers. So we have HBase server is running. So HBase client is a slave.
Oh, what's mean by HBase?
Yeah,
I
it's
was pretty much confused regarding HBase.
HBase is a NoSQL database. Okay, as of now, remember this. We have an HBase session is there, Naveen. Right? I'll give you a complete
Okay, sure.
how to create what is the HBase, how to create the tables in HBase, how we work with, because its main thing is HBase for your project. So every day we'll end with HBase, right? So that's, you don't need to
Okay.
worry. We'll see that one. HBase is there, right? As of now, what is the HBase? HBase is a NoSQL database. In yesterday we have seen that what are the NoSQL databases are there in the interactive session, right? So I have shown you in the diagram as a role of Hadoop developer, what is a admin. So there I told HBase developer, right? It's a
Yeah.
NoSQL database where we are going to create the tables, and we are writing the data into the tables. It's a NoSQL databases. Okay, so right now HBase client and Hive client, right? So these are the slaves.
Okay.
Okay, now you got it. So what are the master nodes and what are the slave nodes? So now my question is, what is a cluster, Naveen?
In this cluster, it's consists of different kinds of nodes.
First word, the first mandatory word. A cluster is a logical thing, which is a collection of nodes,
Yeah, exactly.
right?
It's collection of nodes.
It's a collection of nodes where we have one master and all the slaves are connected to the master. Okay, so in a cluster, how many name nodes we can have? How many name nodes we can able to configure in a cluster?
In a cluster, we can have only single name node,
Okay, it's fine. Uh,
single name node and single data node in single cluster. Is it right or wrong?
no, wrong, wrong. Okay, I'll correct that one. In a cluster, how many job trackers will have? Only one job tracker.
For one data,
Okay,
one data,
in a
for one
class.
name node, one job tracker.
Okay, correct. In a cluster, how many data nodes we can have based upon the data size? Okay, we can
Yeah,
configure any number of nodes as the data nodes. Then in a cluster, how many task trackers we can have?
one task tracker.
Right, how many data nodes you are having? In each data node, we have the task tracker is
In
available.
each data node, we can use only one task tracker.
Yes,
Sorry,
yes. In
in
each
every data node, we can have only one
task
task tracker.
correct. Okay,
Yeah.
right. So this is all the definition is applicable to Hadoop before 2.0.
Okay.
Okay, Hadoop. Oh, my keyboard is having issue.
What is the latest version of Hadoop?
Yeah, okay. Hadoop before 2.0, right? So even it's available in Hadoop after 2.0 onwards, but now what we have a little bit different is available, right? Hadoop 2.0 onwards, right? The new version which we are using in Hadoop is 2.7.0,
Okay.
right? Now see what are the name nodes now. So in a Hadoop 2.0, what are the masters now? Okay, just observe this diagram. We have a job tracker is available in a name node, correct?
Yeah.
Now what this job tracker is doing, first the job tracker is taking request from the client, correct? After that it is going to the
Yeah.
name node to get the reference to find out where the data is available in a data nodes. After that, the job tracker is assigning this job to the task tracker.
Task tracker.
Then task tracker is executing the job. While task tracker is executing the job tracker will monitor the task tracker. Right? It will identify whether you are
Yeah.
working or not. So always, as long as task tracker is working, it sends heartbeats. Yeah, job tracker, please wait. I'm working. It will send the signals. So now job tracker simply is waiting for the output from the task tracker. So once the task tracker completed the job, now task tracker will give the output to the job tracker. Suppose if this data node goes down, then task tracker will stop sending signals to the job tracker. Then what job tracker has to do now? Now the job tracker has to assign the same job to the another task tracker. Then again, this now the job tracker has to monitor this task tracker. Now the task tracker will send the signals to the job tracker. Once the job
Job
is
tracker.
completed, now job tracker submits the output back to the client. Means one person, one process is doing how many jobs here, right? So the entire coordination is done by the job tracker. Okay, got it now?
Yeah.
So
Yeah.
what we did in Hadoop 2.0 onwards is previously we have one employee, right? So only one employee has to do all these jobs. Now what I did, so whatever the responsibility of this particular job, I have distributed to two employees. Now the same job is done by the two employees. Where the difference comes now, Naveen? It can job can be
Task tracker.
faster. No, the
Yeah.
question is
Parallel processing.
yes, parallel processing, and the job can run faster because if you right now you are only one employee working with the job. Now the same job I have given one more employee. You two people are working now, so the job execution
So
will be
can
faster,
you repeat one
right?
regarding the new
Okay,
version?
right. So actually, right now you are only one Naveen. You're working with the job, right? So now what I
Yeah.
did, so whatever the job roles which you are doing, I have distributed to two people. Now you and your colleague will is working on the same job. Previously only you are working on the job. Right now you and your colleague is working on the job. So where the difference comes, when you work alone, it takes a little bit more time. When you two people are working, you are going to distribute the job, right? Some job done by you as well as
Yeah.
some job is done by your colleague, means the job can be done faster way, correct? So the same thing
Yeah.
now, the whatever the job tracker we are having, this job tracker is replaced with a resource manager. Okay, so what we call resource manager. So now we don't use job tracker. Instead of this job tracker, what we use a resource
Resource
manager.
man.
Now in the resource manager, we'll have one resource manager is available and other one is application master is available. Two employees are working now.
Okay.
Okay, so whatever the job done by the job tracker previously, now resource manager and application master is going to do that. So whenever the client submits a request, right? So Now, whenever client submits a request, then the request is taken by the nav whom name node. In the name node, what we have? We have
Job tracker.
no job tracker now. So this is a name node,
This,
and then we are having resource manager. Okay,
yeah.
our resource manager and application
Application master.
master both are available. So first, the request from the client taken by the resource manager.
Okay.
Okay, so resource manager takes a request from the client. Now it will identify the where the data is available. Now in that data node, right? Now this resource manager will assign the job to the node manager. Now what we have, instead of the task tracker, will have a node manager,
Or manager.
right? There is no task tracker now. Node manager is there. So this is a data node. In each data node, we'll have a node manager. Now for a client job taken by the resource manager, and the resource manager will create the resources into the data node. It will create some container, some resource to run the job. Now this job is given to the application master. Now application master is working with the job. Okay, what resource manager will do, it will take the request from the client and it will allocate the resources into the data node. After that, application master is monitoring the job. So while application manager is monitoring the job, then what the resource manager will do, it will take one more request from the client. Means now you are going to do the two things. So request one is processed by the application master. Simultaneously now resource manager can able to take second request from the client.
Client. Yeah.
Right, so this is how the jobs are going to be executed. Suppose you and me are working. Okay, you are a resource manager and an application master. So first, Naveen, you're resource manager. So what you have to do, you have to take the request from the client,
Request from the client.
and then you have to specify the location. You have to allocate the resources. Right now you
Yeah.
have allocate the resources and you told, yeah Ajay, you take care of the job. Then as an application master, I'm monitoring the job. So when I'm monitoring the job, what you're doing now, you're ideal, right? You don't have any work, so you can able to take one more request from the client. So now you're taking the second request. I'm working with the request one. So I'm working with the request one, you're working with the request two. So once I finish the request one, now you give this request to me. So Ajay, take the request two. Now I'm going to monitor the request two. And the simultaneously when I'm working with the request 2, now we can able to take the request 3 from the client. So in this way we can able to run multiple jobs. So this is in Hadoop 2.0.
Okay.
Clear or any confusion?
Yeah. Yeah. Very much clear.
Right. So this kind of environment we call it as a yarn. What we call? We call it as a yarn. Yarn stands for yet another. Let me change the font size. Yet another resource negotiator.
Yet another resource negotiator.
Right, so this is yarn. So this architecture is known as map reduce architecture. The first one is what it is a map reduce. Right, so in the map reduce, what we are having one name node, one job tracker. In the yarn,
One job tracker.
we are having one name node, then
One
resource manager and
resource
application
manager
master.
and application.
Right, in a data node we are having the node managers.
Yeah.
Okay, so now, so in the Hadoop 2.0 onwards, so what are the masters now? We have one name node is available.
One resource manager.
Name node, then resource manager,
Application.
and secondary name node is
Application.
available. Okay, so now if you see this first architecture, suppose if your name node goes down, where your metadata is available now, right? If
In the sec. secondary name node.
No, secondary name node is not a backup node,
Okay.
right? See, actually where the data is available is written into this name node. If it is not available, can we able to see the data into the data nodes? No. Means if this
No.
name node goes down, the entire cluster is down.
Okay.
Okay, first point. Second one is name node writes its data into primary memory. Primary memory means temporary memory. Means if you shut down this machine or if this machine goes down, the content is going to be erased. So when you make this name node up and run, so can we able to retrieve the data? No, right? That means,
No.
so in this case, if your name node goes down, so the entire cluster is down. Correct? So
Yeah.
this is one issue. So it's not fully available. So what we are going to do in Hadoop 2.0, we are taking one more name node. How many name nodes we are taking? Two name nodes,
Two name nodes.
right? So now we can able to configure multiple name nodes here. So this is what we call name node 2, or some people will call it as a shared node. What we call? We call it as a shared node,
Shared node.
or some people will call it as a HA node. HA node means high availability node. Okay,
Oh,
we call it as a HA node. Shared node or HA node. Now we have a client, one name node and another name node, and we have secondary name node is available, right? So in a
yeah.
Hadoop 2.0 onwards, it's a secondary name node, right? One name node,
In
one.
MapReduce, we are having the primary node, primary name node.
Yes, this is it's right. It's a primary name node. This secondary name node. Here, this is a
Okay.
primary name node, a secondary name node, a shared node. It's
Okay.
simple thing, Naveen. We are taking whatever you are writing in the name node. I am also writing into this node. Two writes now, right? To
Okay.
backup.
I got it.
So whatever you are writing to the name node, the same I am going to write into the shared node. So if your goes down, then automatically I'll make this node up and run, so that I can make the cluster available 24 by 7,
Yeah.
right? So we call this extra node, another node as a shared node or HA node, high availability node,
Yeah.
right? Now see, so in a Hadoop 2.0, how many name nodes we can have?
Two name nodes.
Yeah, it can be multiple now. If you want to take the backup, you can take backup into multiple disks now, right? So generally it's a two or three, it's up to you. We'll say two name nodes, correct? Right? We have a name node, then HA node, high availability node, and then a secondary name node, and then resource manager, then HBase master by HBase master, or if you configure Hive server. So these are all
Sure.
comes as a master nodes.
Yeah.
Now what are the slaves? Data node
Uh, Data node.
and node manager,
Node manager.
and so HBase client, Hive client. So these are the
Okay.
slaves, right? So this is having. Now suppose my requirement is different. I'm having this Hadoop with a yarn. Now I want to run a MapReduce job. Is it possible? Yes. We can able to run a job with a yarn. We can able to run a job with a MapReduce. Okay. So here in this one Hadoop 2.0 onwards, we can able to use a MapReduce as well. We can able to use a yarn. So I want to work with a job tracker. Yes, we can start the job tracker and we can work with the job. You want to work with the resource manager? Yes, we can also work with the resource manager. Both are available.
Okay.
Okay, that is in Hadoop 2.0. But in before Hadoop 2.0, only job tracker is available. We don't have the yarn available here. Okay, so means the job which you're writing is going to be a MapReduce job. It's mandatory in before 2.0. In Hadoop 2. After 2.0 or 2.0 onwards, it cannot be a MapReduce. You can write any job on Hadoop cluster, right? So that's a
Okay.
non-map reduce. And if you want to write job tracker to run the map reduce job, yes, you're writing a non-map reduce job on the yard. Yes, you can run,
Yeah.
right? So this is Hadoop 2.0 onwards.